Hey, we have here today another integral from the MIT Integration Bee. This was from 2023, regular season, problem 7. We have the integral of dx over the square root of x plus 1 cubed times x minus 1. Okay, to get started with this, I didn't have any great ideas, so I was just going to do the straightforward thing and kind of work with the denominator and try to split this up. Looking at this x plus 1 cubed, what I want to do is split this into two parts. I can write this as x plus 1 squared times x plus 1, but then multiplying this x plus 1 times the x minus 1, I can write this piece here as x squared minus 1. So let me just rewrite this whole thing and see what we have. And with this x plus 1 squared inside the square root, I'm going to bring it outside of the square root in the denominator. And so we'll write this here. And we'll have our square root. And then all we're going to have left is this x squared minus 1 inside the radical. So we'll write that and continue. And then at this point with x squared minus 1 inside the radical, this looks pretty good for a trig substitution. And because we have x squared minus 1, what I'm going to do is make my substitution for x equal to secant of t. Then I'll take my derivative here. So for our dx, we're going to have secant t, tan t, and I'll go ahead and substitute this thing. So we'll have this in the numerator. Just write that out. Then in the denominator, we're going to have a secant t plus 1 here, and then inside the radical we'll have secant t squared minus 1. But secant squared t minus 1 is actually the same thing as tan squared t, and we're inside the radical, so this is going to become tan t. I'm just going to cancel that with one of these here, and we're just left with what we have over on this side. Okay, now at this point what I'm going to do is multiply this by 1. We'll multiply it by cosine t over cosine t. We don't really have to do it. We could work with secant, but I just felt more comfortable with the cosine, so we'll multiply that in here, and cosine times secant is just going to be a 1 in the numerator, so we're just going to have a dt up there. And then multiplying this in, we're going to end up with 1 plus cosine of t. But then from here, I'm going to multiply through again by 1 minus cosine t over 1 minus cosine t, again multiplying by 1. And the reason is when I do this in the denominator, this is going to give me 1 minus cosine squared of t, but that's actually the same thing as sine squared t. So let's just rewrite what we have. But then what I can do is split this up into two integrals. So the first one with the sine squared in the denominator is going to be the same thing as cosecant squared t, which we know how to integrate. And then for the second one, instead of writing this as cosine t over sine squared t, you'll notice if I break up the sine squared t, I can write this as cotangent t times the other sign, which is going to be cosecant t. But now we can go ahead and integrate, and each of these integrals is really well known, so doing this first one, the integral of cosecant squared t is going to be the same thing as minus cotangent t, and then the integral of cotangent t cosecant t is going to be the same thing as minus cosecant t. But here we have minus times minus, so let's just write that as a plus, and let's actually get rid of this one because we don't need it. And now that all of our integration's done, we just need to get this back to x. We have this in t, and what we can do is go back to our original substitution and use this. And what I'm going to do is draw my right triangle to figure some things out. So we'll draw this right triangle, 90 degrees there. Angle is going to be t. Now we're saying secant of t is going to be x over 1. Secant is hypotenuse over adjacent, so we can put an x on our hypotenuse and we can put a 1 on the adjacent. But then with the Pythagorean theorem, we'll just find our third side to be square root of x squared minus 1. So now that we've set up some values for all three sides, we can find our values for cotangent t and cosecant t. So let's get cotangent t first. So cotangent t is going to be adjacent over opposite. So that's going to be 1 over square root of x squared minus 1. And then cosecant of t, this is going to be hypotenuse x over square root of x squared minus 1, our opposite. So let's just plug these values in here and see what we have. So we're going to have minus 1 over square root of x squared minus 1. And then for here, for cosecant, we're just going to have our x over x squared minus 1. Well, we have the same denominator, so we can put these two together, and we can write this as an x minus 1 in the numerator, and then we'll have our square root here in the denominator. But I can take this and rewrite it back the way we had it originally, which is x plus 1 times x minus 1. And when I do that, I'll rewrite that. And let's just notice we have the same thing, x minus 1 here, but we'll have a power of 1. So I'm just going to write it that way so we can simplify this. And so I'll actually break this up a little bit. So having the x minus 1 in the denominator and x minus 1 in the numerator, we can actually combine those terms and write it all under one square root. So for our final solution, we're just going to have the square root of x minus 1 over x plus 1 plus c. And that's it. We'll stop it there. Thanks everyone for watching. Have a great day.